Welcome to this recycling engineering project, which is extremely unique and groundbreaking. We will transform an ordinary washing machine motor into a high-capacity alternating current generator. The washing machine motor block is lying on the table. The first step is to remove the protective metal base frame. The technician is manually removing the retaining clips and the protective bars underneath the motor. Next is removing the central row of screws to disable the fixed point of the machine's rotating shaft. Remove the aluminum protective cover. We can immediately see the stator coil, made of pure copper. These coils are wound extremely tightly and arranged neatly inside the metal frame. The technician uses a metal drill bit to drill decisively through the aluminum casing of the motor. This mechanical intervention step is to pave the way for structural customization right after. This is the most crucial step, taking the squirrel cage rotor out of the stator core to modify its structure. Using a blue marker and a steel ruler, the expert is drawing spacing lines. Marking the surface of the steel rotor requires meticulousness to ensure symmetry. The precision at this stage will determine the stability of the magnetic field when the generator operates. Based on the reference lines, the drill bit goes deep, creating small grooves on the rotor's surface. The metal structure of the rotor is being completely transformed in preparation for the magnetic flux generation process. Here is the key point: preparing the permanent neodymium magnets with super strong magnetism. The magnets are dipped in a specialized adhesive solution to increase adhesion when embedded into the rotor. Each magnet is accurately and carefully inserted into the newly drilled holes on the surface. Continue using metal pins or small screws to securely lock the magnets inside. This operation prevents centrifugal force from dislodging the magnets when the generator spins at high RPM. Embedding the neodymium magnets has officially turned the passive rotor into a completely active magnetic rotor. The upgraded rotor assembly is carefully reinstalled back into the center of the original stator core. The technician puts the motor's protective cover back on. The phase wires are carefully routed through the gap. The blue, red, and yellow wires are neatly pulled out through the exit hole to prevent breaking or short circuits. Insert the thick locating bolts through the slots and thread them by hand before tightening the casing securely. Use a screwdriver to tighten the bolts and manually spin the shaft to ensure the mechanism doesn't rub against anything. A flat wooden board is brought in to serve as a sturdy base for the entire generator system. Pump plenty of hot melt glue onto the wooden board, then press the generator block onto it to secure its position. Continue reinforcing with hot melt glue, ensuring the motor block is firmly attached to the wooden board. Place a standard 3-prong electrical outlet next to it, preparing to connect the voltage output. The technician pulls the phase wires from the stator neatly toward the electrical outlet. Use wire strippers to remove the insulation, exposing the copper core to connect with the conductive metal contacts. The copper cores are carefully connected to the metal pins of the plug, creating an electrical transmission path. Secure the connections with zip ties and heat shrink tubing to prevent short circuits. On the generator's main shaft, a plastic drive gear is installed to receive power. Use screws to firmly secure the gear to the rotating shaft, ensuring there's no slipping during rotation. A small DC motor is introduced to serve as the mechanical power source. A specialized rubber drive belt is used to connect the two drive gears together. Loop the drive belt around the generator's gear and the small pulley of the DC motor. Secure the DC motor with hot melt glue, stretching the belt to maximize transmission force. Use a soldering iron to connect the blue and yellow power wires to the 2 terminals of the DC motor. The 4 power wires are neatly routed underneath. The electromechanical block is ready to test the power generation capability. The technician uses a traditional clamp multimeter to prepare for measuring the output parameters. 1. Adjust the scale to the AC voltage range. Plug the 2 test probes into the socket holes. 2. Fine-tune the clamp meter to 0, ready to observe the induced current generated by the device. 3. Try plugging an incandescent light bulb into the socket. The powered DC motor starts driving the generator. 4. The light bulb flashes blindingly bright, proving that the AC voltage generated is extremely stable and powerful. A more rigorous test with a 3-way splitter and high-capacity light bulbs. The generator still provides enough energy. The light bulbs shine brilliantly, with no flickering or voltage drops, even under a heavy load. This is a testament to the principle of electromagnetic induction. Kinetic energy is effectively converted into electrical energy. The super-strong magnetic flux of the neodymium cuts through the stator coils, generating an alternating current that exceeds initial expectations. The process of customizing the motor of an old washing machine into a mini generator has been completely successful. The drive system runs smoothly, providing an abundant electric current, an incredibly innovative energy solution